Hi guys, we're going to go over the examples at the top of your empirical formula practice worksheet. Oh, I got my little co-star Braden here. We'll see how he does. All right, so it says example 1, a piece of iron ore is found to contain a compound containing 72.3% iron and 27.7% oxygen with a molecular mass of 231.4 grams. So for your grams of element, you take your percentages and you convert them directly for grams. So 72.3% iron becomes 72.3 grams of iron. All right. 27.7% oxygen becomes 27.7 grams of oxygen. So now we're going to put in our molar mass of our element, and this is as found on the periodic table. So iron is 55.845 grams. Yeah. And then oxygen is 15.999 grams. And now what we're going to do is our grams, so the first column divided by the second column. So your grams divided by your molar mass. So 72.3 divided by 55.845 gives me 1.29. What did you do? 1.2947. Goodness. And then for your oxygen, we do 27.7 divided by 15.999. And that's going to give me 1.7314. So then what you do is you're going to divide this by the smallest of these two numbers. So the smallest of these two is this one right here, the 1.29. So I'm going to divide by the smallest number and then put this in a whole number. So 1.2947 divided by 1.2947 is 1. For the next one, the 1.7314 divided by 1.2947 becomes 1.33, so we're going to round that to just 1. Now, if it's 1.5, you have to multiply both of these by 2, but because it's not, you can just make it 1. So that means my empirical formula is going to be 1 iron to 1 oxygen, or FeO. Oh, I have a percent sign. FeO. Okay, so now let's do the empirical formula mass in grams. So what that is your number of irons plus your number of oxygens. So I have 1 iron at 55.845 grams. Plus 1 oxygen at 15.999 grams. Yeah, that's right, bud. So we're going to add those two together. 55.845 plus 15.999. And that gives me 71.844. No, you cannot have my calculator. And that's going to be my empirical formula mass in grams. So I'm going to take the molecular mass as found in my problem, which is right up here. The 231.4 grams. I'm going to divide that by the empirical formula mass we just calculated, so 71.844. And I'm going to round this to the nearest whole number. So 231.4, yeah, divided by the empirical mass in grams gives me 3.22. So I'm going to round that to 3. So my molecular formula becomes Fe3O3. Okay, so that's how we did the first one. So let's do the next example, and I'm going to do 3 examples for you. All right, on the next example, it says a compound containing 40% carbon, 5.7% hydrogen, and 53.3% oxygen has an atomic mass of 175 grams per mole. So again, my grams of element, I just convert these percentages directly into grams. So the first one's going to be 40.0 grams of carbon. The next one is going to be 5.7 grams of hydrogen. Then we have 53.3 grams of oxygen. I'm going to write down the molar mass of the element as found in the periodic table. So carbon is 12.011 grams. Hydrogen is 1.008 grams. You want this? Take that. Take that. Take that. There we go. And then oxygen is 15.999 grams. So then I'm going to take this first column divided by your second column. So 40 divided by 12.011 becomes 3.330. Right. 5.7 divided by 1.008 is 5.655. And then oxygen is 53.3 divided by 15.999, which is 3.331. So I'm going to divide by your smallest one again. So my smallest one is this first one this time. So I'm going to get 1 for the first one. Then I have 5.655 divided by 3.330. That's going to give me 1.69, which will round to 2. And then 3.331 divided by 3.330 is 1. So my empirical formula for this one is going to be 1 carbon, 2 hydrogen, 1 oxygen. So CH2O. So now my empirical formula mass in grams is going to be 1 carbon, 12.011 grams, plus 2 times the mass of hydrogen, plus 1 oxygen. Which will equal 12.011 plus 2 times 1.008 plus 15.999 is going to be 30.026 grams. Thank you, Braden. Okay. Now my molecular mass divided by my empirical formula mass. So my molecular mass, again, is given to me in the problem. It was 175. I'm going to divide that by that number we just calculated, the 30.026. That's going to give me 175. Gives me 5.828, so that's going to round to 6. So that means my molecular formula is going to be C6 H12 O6. And remember to get the little subscripts at the bottom. I just hold down Control and comma, and to get them to go back away, I hold down Control, comma again. All right, and let's do example number 3 now. Example number 3 has 4 elements in it, and I'm actually going to enter this down so it's all on one page. I think it's a little bit easier to read that way. All right, it says a compound is 59.0% carbon, so 59.0 grams carbon, 7.15% oxygen, so 7.15. If I say oxygen, I meant hydrogen. 26.20% oxygen. And finally, 7.65% nitrogen. So again, I converted those all directly to grams. Now I'm going to write down the molecular mass as found, or molar mass as found in the periodic table. So carbon is 12.011 grams. Hydrogen is 1.008 grams. Oxygen is 15.999 grams. And nitrogen is 14.007 grams. I'm going to do first column divided by my second column. Why are you kicking my computer? Here's your hippo. Where's your hippo? All right, 59 divided by 12.011. And if you notice when I do these, I leave several decimal points. And that's just so I'm not rounding until the very end. All right, for hydrogen, 7.15 divided by 1.008. 7.0933. Yeah. 36.20 divided by 15.999. 1.6376. And then my last one, 7.65 divided by 14.007. That's 0.5462. All right, so my smallest one, this one is my nitrogen one. So that's what I'm going to divide all of them by. .9122 divided by 0.5462 is 8.99, so that's going to become 9. I have 7.0933 divided by the 0.5462. That's 12.98. That's going to become 13. 1.6376 divided by 0.5462 becomes 2.99, so that's 3. And then my last one is just going to be 1. So my empirical formula now is going to be C9, H13. Oh gosh, what's it? O3. All right, for my empirical formula, mass in grams, I'm going to do 9 carbons plus 13 hydrogens plus 3 oxygens plus 1 nitrogen. And I'm not going to write that out this time because I don't have enough space, but I'm going to do it in my calculator. So I'm going to have 9 times the mass of carbon, which is 12.011, in parentheses, plus sign, parentheses, 13 times 1.008, close parentheses, plus sign, open parentheses, 3 times 15.999, close parentheses, plus the mass of nitrogen, which is 14.007, and I get 183.207 grams. My molecular mass is given to me in the problem was 183. 183 grams divided by 183.207 is going to give me 1. So that means that the empirical formula is also the molecular formula in this problem. So I can just copy and paste that then. And then that is how you do empirical formula problems. On your assignment today, which I'm going to scroll through real quick with you, some of them you're only going to be asked to do empirical formula. So 1, 2, 3, 4, 5, 6, 7 is just empirical formula. 9 and 10. 9 is asking you to do molecular formula from number 7. And then 10, 11 are molecular formula from an empirical formula. So it already gives you the other stuff, so you just have to find the molecular formula. And then 12 and 13, you're doing the whole thing like we did at the top. So if you have questions, message me, and we will talk to you later. Say bye-bye, Brayden. Say bye-bye.